Hi class, we go to the next example. Previously, you have learned how to solve ordinary differential equation using separable method, but the problem that you got, there is no initial condition. But now we want to solve the initial value problem. Means that you have equation of ordinary differential equation together with its initial value. Here we have the problem of dy dx equal to y minus 1 over x plus 3, whereas here we have additional information that is y negative 1 equal to 0. If you back to the week 1 slide, so in this case, you can get particular solution instead of general solution. Means that previous example, you got general solution, but now when we have additional information here, which is initial value, so you will got the solution here in terms of particular solution. Now class, we will go one by one how to solve this problem. So the first step, you need to write this equation in terms of separable equation. You can actually move this y minus 1 to this side and dx you move to the other side. So we will have here dy divided by y minus 1 equal to 1 over x plus 3 dx. And then step number 2, we will integrate both sides here. And actually this one, where you got 1 over something function or 1 over some function, means that the answer should be in terms of logarithm. That is here. We integrate 1 over y minus 1 dy. You will got here ln, okay, y minus 1. And then integrating of 1 over x plus 3 dy. So we'll got here ln x plus 3. Instead, in this case, you have to put here c. Okay, because at first, it is in terms of general solution. But later, you can substitute initial value problem to get particular solution. Means that for step number 2, by integrating of 1 over y minus 1 dy, which is equal to the integration 1 over x plus 3 dx. We'll got here this part ln y minus 1 equal to ln x plus 3 plus c. And then class, remember, you cannot leave your answer like this, but you have to write y as subject. How to write y as subject? First, we move this ln to this side. We collect all ln with, at the same side. So here we will have ln y minus 1 minus ln x plus 3 equal to c. And then remember, law of the logarithm, when this one is minus, we can write in terms of division. So we will have here ln y minus 1 divided by x plus 3 equal to c. And then class, remember previously we have the same kind, the same pattern of the solution like this. This ln you need to move to this side. So you will have here y minus 1 x plus 3 equal to exponential of c. And in this case, I can write this exponential of c as a constant a. So I will have here y minus 1 x plus 3 equal to a. And then I can move this x plus 3 to this side. I will have y minus 1 equal to a times x plus 3. And then I have here y minus 1 expand this function ax plus 3a. When I move this negative 1 to this side, I will have here y equal to ax plus 3a plus 1. And then class, you have previously initial condition. which is initial condition is given by y negative 1 equal to 0. Remember, this one is the value of x. When x negative 1, you have y equal to 0. So we need to substitute x and y here in this equation so that when we compute, we can get the value of a. In this case, I substitute x here with negative 1. I substitute y with 0. I have here 0 equal to a times negative 1 plus 3a plus 1. In this case, I can solve this one. It is actually 3a minus a. So I have 2a plus 1 equal to 0. When we solve this, so I write like this, 2a plus 1 equal to 0. I have 2a equal to negative 1. I solve for a, so a equal to negative 1 over 2. And when we got this one, means that to get the particular solution, this a, you need to substitute in this y. So we will have here our solution y equal to negative 1 over 2x plus 3 times negative 1 over 2 plus 1. In this case, you can solve this part, okay? Which is we have here equal to 1 over 2x plus, minus, because here plus minus 3 over 2. This one make a denominator equal, so it is plus 2 over 2. So our final solution y equal to 1 over 2x plus, minus 1 over 2. So this is our final solution. Sorry class, here I miss here negative 1 over 2. So negative 1 over 2x minus 1 over 2. This is how can we get a particular solution using separable method. Next class, we go to the application problem. Sometimes I will ask you application problem instead of general mathematical problem. So now we go to this application problem. We have, for example, the population, which is this population is denoted by notation P of a town. We said the population of the people in one town is initially at initial time is 7,000 people only, and it is growing at a rate of dPdt, means that rate of change for that population with respect to time is equal to 0.08 people per year. So the question asks you to find the town's population in 10 years. How to get this one? You need to find P, population at time 10. So we want to compute the population of the people when this t equal to 10 years. So here, what is the number of this population? How to get this p? Because now you have here in terms of the PDT, means that you need to integrate the function. Okay, integrate the function, or means that you need to solve this ODE. How to solve this ODE? So class, we have here dp dt equal to 0.08 p. So now we use separable method. So we can move this one to this side and this dt to the other side. Means that for step number 1, I will have here dp over 0.08 p will be equal to dt. In this case, when we integrate both sides here, okay, I will have this one integration of 1 over 0.08 p dp equal to integration 1 dt. So integrating this part, remember, we can write here as 1 over 0.08 integrate 1 over p dp equal to integrating this one, you got t plus c. Okay, and then when we integrating this part, we will have here 1 over 0.08 ln P equal to T plus C. And then I can move this 0.08 to this other side. So I will have here ln P equal to 0.08 T plus 0.08 C. But this one, I can just write in terms of A. So I have here ln P equal to 0.08 T because this one just constant, okay, which is plus A. And then class, remember, we need to write at this side at just P. So we need to move this ln here. So I have P equal to exponential of 0.08 T. When I move this ln to this side, for this one, it's become actually exponential of A. Okay, because this one, the rule of exponential is become multiplication here. And for this part, I can write this one, for example, as another constant K. So I will have here P equal to K exponential of 0.08 T. Now, I got this solution in terms of general solution. But already given to us a time here. Okay, the question asks the value when we have here 10 years. And in the question, we have actually initial value. Based on this, you can extract the initial value from this information. Means that initially there are 7,000 people. When we mention this one initially, so at this, our time is equal to 0. Means that the population of the people initially is 7,000. So I can transform into mathematical term, which is the population of the people at 0 time, it is equal to 7,000. So you can use this information to get the particular solution of this problem. So that class what we have got previously, we have here P at initial, there are 7,000 people. We have solved the ordinary differential equation, whereas P we got equal to K exponential 0.08 T, and the question actually asks the value for 10 years. What are the population of the people in that town? So now, before we find this one, you need to find the value of K based on this initial value. Because now you need to find a particular solution so that you can get the P at 10 years. How to get this? Okay, so we have here T equal to 0, P at 0 equal to 7,000 people. Means that when initial is time is equal to 0, this P we can substitute with 7,000 people, which is equal to K exponential of 0.08 times 0, which is T here we substitute with 0. In this case, this one exponential of 0, you use your calculator, you will got equal to 1. Means that directly we can get K here equal to 7,000. So based on this, we will have your particular solution P equal to P at time T will be equal to 7,000 times exponential of 0.08 T. So now class, when we know that we want to find population at T equal to 10 years, we will have here P at 10 years will be equal to 7,000, and this T you need to substitute with 10. Okay, when we solve this one using calculator, we'll got here the answer equal to 15,578 people. Means that here for 10 years, you will that town will have 15,000 15,578